plan for this Databricks till, you know. So like today, we're going to discuss some of the refresh of Python because maybe participants are aware or not aware. So accordingly, we have indulged that. Okay. We talk about a bit of pandas, NumPy and some case studies around that. Okay. We'll look around, those things. Okay. Moving forward, since I believe you all have received your AWS labs, right?
Yeah, received the mail
Yes.
actually, but in that mail I have not received the credentials.
Credentials
Yeah.
would receive because you might be
Yeah.
something.
Yeah. Might we'll discuss on that. Maybe everyone has received credentials as well.
Okay.
Okay, maybe you
Something
to
like
check
this you
with
need
us. Yeah.
to I'll show you how to log in with based on login ID and password.
The same I am saying actually login ID and password I have not received, but yeah, we can discuss it.
Okay, that's not a problem. So apart from that, forwarded, we will be discussing on like how to, some basic overview of AWS in our coming sessions, and then how we can, do some security and everything around a bit of AWS understanding for an hour, and then we can start discussing the PySpark part. So we'll be discussing how PySpark on the top of the Spark API, how does it work around. And for that, we'll be discussing how AWS Databricks is working. So AWS Databricks we'll be going to set up. Then, we'll be going to understand the user interface of Databricks, how the Databricks and everything looks around, how we can set up the storage data lake of Databricks over, AWS, and how we can start reading and writing the data. We will start making some transformation on the top of it using PySpark. Multiple other transformation techniques are there. Some functions around that we will be discussing. Then different advanced PySpark techniques we can also look around, like performance tuning and something like that. Those kind of things we'll be looking around PySpark, and not just this, a bit of Spark MLib understanding, and also those special understanding we can look around. So that is what the plan for the coming day 4, and then day 5. So this I have created till six days in which we'll be discussing all around Databricks, PySpark, and everything. Maybe it can go one more days or like that. So we will look around there. So this is how, and then Spark streaming, data catalog I have mentioned in the advanced Databricks part, right? So this is the idea. Okay. I will also share you, Vijay, then you can
Yeah.
share. Yeah. So that is the idea. Right now we have a structured idea like how we're going to proceed the session further, right? So yeah, let's move around and we'll see like how we can, proceed. So today, first of all, I believe for those who received the credentials, let me just show you how you're going to access the labs. So once you're going to, logging into this Cloud Nebo Pro, something like this, okay. Here, once you're going to log in, it will be going to open like this. Okay. It will be going to open like this. You just need to do what? You need to start the AWS Web Service account lab. Okay. And once you start this, you will get this link jump to console, right? So as you will click jump to console, it will going to start your console here like this, the AWS dashboard. You'll start getting this like this. So can you quickly check? We can test the lab, those who have access. So, further you don't have any problem. So that is just start.
Okay. After some time, we got to start.
Yeah. No worries, that will be communicated. I believe you got to know like how to access this AWS Home Console, right? So this is what we're supposed to gonna work from our coming session. So as of now, the today idea is to get it, let's understood the some basics of Python, because see the idea is that we with the help of PySpark on Spark we are supposed to gonna do transformation and all, and Pandas is one of the most used package, right? If somebody's are using it, like how to use why it is important. So, how many of you are not used Pandas NumPy before? Can you just quickly type in the chat box? Hello.
Most of us did not use it
Most of you guys have used it,
and did not use it.
did not used it.
Yeah.
Okay. So, okay. Let me just start the, stuff and accordingly.
Stopping my screen sharing.
Good enough. So I believe all of you, know about basics of Python. All of you know some basics of Python. First of all, I believe yesterday you might have got a chance to download, Anaconda. All of you have installed the Anaconda.
Yes.
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 So I believe you all have installed the Anaconda and with the technique that I've told you, right? And once it get installed, the major user interface that we're supposed to gonna use is the Jupyter Notebook. So Jupyter Notebook is what like Anaconda is a cloud aggregator, aggregator where all the tools related to data science are assimilated. But apart from that, in this, we are primarily going to use Jupyter Notebook, right? So either you open Anaconda Navigator and then you launch the Jupyter Notebook, or you can actually directly search in your search bar Jupyter, and I believe and you can start, going to use a Jupyter Notebook, right? So once you open the Jupyter, once you click on the Jupyter Notebook, it it will be going to open on your, local web interface, like this. So in a local web interface, what is there is like in your interface here, you can see that um, it's start going to give you a, like a way to launch your Python notebook. So here you can see that, this is the interface where, all your folders and files and data you can upload and start writing the program, and it automatically save in certain folder that has been dedicated to, in C somewhere. So you can do one thing, since it's already a pre-installed Python, is there, you can use R or some other languages also here. Just need to add the APIs and all for that. It's Python 3 you will receive. So once you click on this, you will get this kind of user interface. Yeah. So you can see that this interface is there where and let me tell you, when you use Databricks, okay, Databricks also has similar kind of user interface where little bit change, but they have also maintained their notebook in cell format. Okay, you can see this is a cell, okay, where you can write your program and user can like once they debug, like the other output will come over there, and that's how the interactive kind of a notebook kind of a structure is there, right? So all you are able to access your Jupyter notebook now.
Let us try.
Yeah. So here, let's say, since this is our very first, program here, so we can write here, Python basics. So once we rename it, now you can see that this is a cell where we're supposed to gonna write our program. So let me just quickly tell you this user interface also. So here, when you click on Python notebook, you can create a new notebook also. You can open a new notebook. You can copy, save, rename, save and checkpoints, download these things you can do here. You can edit something, you can split the cell, you can move cell up, down like that. These are the information in edit is there. You can view, you can insert, you can, create another cell. And the most important is kernel. Kernel is what? Since we are running Python, so Python is being installed inside your system using Anaconda itself. Now, when this, uh, what we say, uh, this web UI we have right now, the local host, this local host is connected to some kernel, some kind of a running software behind that. So, when we debug the code, it is running behind this kernel over there. You can see that this is the kernel that is connected, and this user interface here on localhost, we are accessing this notebook, right? So now this user interface of web UI is letting us connect to the kernel. So sometimes you face problem, when you are debugging the code, it shows some error because of kernel, because kernel sometimes try to reconnect also. Okay, so that's why we can restart the kernel, we can reconnect the kernel, we can shut down, multiple options you will get around it here, right? So we can start writing the basic Python code here. Let's say whenever you want to make a print of any certain your name or anything, or just printing the hello world. So whenever you do this, when you shift enter, you can see the output here, correct? This is the output you will receive here. And apart from that, since it's a kind of a right now, a kind of a code we are writing here. If you want to change the type behavior of this cell, you can write this behavior as a heading or markdown or something like this. So I'll show you. Let's say I wanted to highlight, like this is my first Python. Let's say I wanted to write here my right. When you shift enter, you will get this kind of user interface. Also, you can also put images inside the cell. So kind of an illustration or something like this. Everything can be assimilated in Jupyter Notebook. So that is what about the user interface of Jupyter Notebook, right? Now, please allow me that here we or everyone know the basics of Python, like the data types and those things, right? Everyone is good to know that, aware of that.
Yes.
Yeah. So you know that in Python we have 7 different operators, then the 6 type of data types, like we have numbers, we have list, we have tuples, right? We have dictionaries,
Sets.
right? Sets, and what we forgot here is string. So these are the one in which numbers, tuples, and strings are immutable type of data type, whereas list, dictionaries, and sets are mutable type of data type. So if anybody will going to tell me what is mutable, immutable, quickly,
Mutable can be changed.
correct? So yeah, I mean that is what, and yeah. So this is a triple quotes. Now moving further, if we know all the basics of Python, then see there are some important packages because we are doing kind of a EDA, or you can say that ETL stuff. So for ETL and EDA kind of thing where we have to transform the data, there are some certain packages available of in Python. That is NumPy. We have Pandas, right? And we have Matplotlib for exploring the data, visualizing the data, and Seaborn also. So, these kind of packages that's help for doing ETL, EDA kind of thing, right? So these are important one. So if we talk about NumPy, and how many of you have used NumPy before? Yeah. So NumPy is nothing but it's a numerical scientific Python package. Okay. It's a numerical, scientific package where you have all the numerical related, statistical related functions are there. Let's say you have any kind of data, if you want to convert those data into form of array or something like this, you can use NumPy, right? So, like I will give you an example. Let's say you have a list, okay, list of values, and on either list we have, let's say called, y, and so these lists are there, and you wanted to convert this in a form of an array. Okay, so how do you convert in a form of array? For this, you import in package, import numpy as np, and like if you wanted to convert an array, so here I'm just defining np dot array, and here I have x, comma, y. So you can see that when I just print this, hmm, import,
Near import, yeah.
yeah. You can see that this is an array. So here, like if you print the type also, it's an array type. NumPy.nd array, n-dimensional array, right? And it will allow us to, it will also allow us to print an array as well as finding the shape of this array, like we have this here. So it allows us that it's having 2 rows and 4 columns. If you want to find out the size, okay, so it's also allow us to know the size. That's called uh, here we have the size is the total number is 8. You can got to know the np dot ndim dimension. So here you get to know that it's a 2-dimension array. Similarly, you can create 1-dimension array as well as. So yeah, and then moving forward, if you want to reshape it, reshape because it's a 2 rows and 4 columns. So if I wanted to reshape in 4 rows and 2 columns, that's also possible. So what? Yeah. So this array that was in 2 rows and 4 columns has been converted into 4 rows and 2 columns. Got the point? Yeah. So apart from that, if I just ask you to, um, you know, um, okay. So can you do one thing? Just quickly, I want to check, like, can you convert this into a flattened list? I want something, your output should be like this. Means, um, you know, 2, 3, 4, 4, 5, sorry. Yeah, it should be like this in a one single list. 2, 3, 4, 5, 4, 5, 6, 7. In a one single list.
One-dimensional array.
Yeah, one-dimensional array. I wanted to convert into one-dimensional array in which all the values will be residing inside this. Everything, whatever it is inside one. Quickly do this.
So reshape array of 1, comma.
This one is here. Let me just quickly share this with you guys. Just close it. Just close the both. This one, first one, just close this one. No, not this one, this.
Oh, okay. Let me reopen it.
Yeah. And show me the another user interface. No, not this one. No, don't do anything. Just go on to this Linux, oh sorry, CMD command. The command that is showing to you of Jupyter Anaconda.
Okay.
Then first, no. Okay, just close.
Anaconda
Let
from?
me start the Jupyter notebook once again. Just close all these two, commands that is opened over there. Okay, just close it. Close this one as well as, and just go on the Anaconda dashboard. Anaconda navigator. That's you already opened here. You can see you have already opened that.
Hmm.
Yeah. And are you getting user interface of Jupyter here? Just scroll down below.
No.
There are some problems.
Anybody else facing this issue?
I was facing, but I directly installed Jupyter Notebook.
Yeah, I am also installing directly.
Yeah, through VS Code also we can open Jupyter Notebook.
Then what is there also?
Through VS Code directly, we can start the notebook.
From where, Nikhil?
Let me give a second. Let me share my screen.
Okay.
Just check that. This code is here. So I'm using currently is the VS Code notebook. So we have to. Okay. No, why the screen is.
Maybe Nikhil, maybe they can use this Python directly in Python. They can install, right? And that
No,
directly they can use like open the Jupyter notebook in CMD. The similar kind of.
yeah, that fashion, that also we can try. But if it is already it is installed, right? Then we can just say a new file. Okay, and if the Jupyter notebook option will come, IPython
Mm-hmm.
notebook, click, it will open. So we can use same functionality here,
Mm-hmm.
and later it will execute. It will execute. If the VS Code is installed, then we can directly use.
Otherwise, there is a, you can do array dot Latin, and then you can convert into list. So all the stuff has been came here. That is the idea. Now moving forward, like this is some basics of NumPy, and this the why array we are discussing, because array is actually helping us to do multiple things. So let's say if I have to do some, or maybe find out the statistics like mean, median, or anything else, that's actually help us. So let's say on certain rows and column, I wanted to do some. Let's say I wanted to do some on array, and this array is here, so it's going to print the sum of the whole array. Apart from that, if I wanted to print the sum based on axis, okay, axis means I wanted to go by rows, or either by column, so I can do the same. I can actually define array into basis of either rows and column. So either it should be axis 0 or axis 1. So you can see that based on axis 0, this is like this. Means 2 plus, like if you can see 2 plus 4 is 6, 3 plus 5 is, that's 8. Then similarly, it has been, taken up. Now, if I wanted to do based on columns and all, so I can actually do this. So here you can see that. Here based on axis 1, I can get this axis based on columns. So the same thing we can do for other parameter like mean, median, mode. So you can easily find out the mean here, mean. Yeah, so that is something you can do that. And again, median and standard deviation, those all functions are there, right? So yeah, I mean, that is what, like we can actually look around this, and we have defined the NumPy in this way. Now moving forward, like apart from that, there are so many other functions that we does not require as of now, but yeah, I mean, we can do that. A lot of things you can look around the NumPy. So the next package that we will be discussing is called Pandas. So let me just tell you what is Pandas. Just show you some documentation for that.
Deepesh, this NumPy is only for working with arrays, or any other functionalities are there?
No, there is a linear algebra functionalities are there, like if if you wanted to talk about the linear algebra functionality, like talking about the transpose, matrix creation. When we little go into the machine learning side, the complete NumPy will be getting used, like
Okay.
creating linear algebras, algorithm, and those kind of thing will help you. Vectorized form of an array, so that way it's actually help, like calculation of two different arrays. When we do principal component analysis, we need to do multiple things. So it is actually helping us to make the data into complete linear algebra structure. Like if you wanted to create, do you know about identity matrix?
Heard of it?
Yeah. So you can create an identity matrix of, like, so identity matrix are those that goes on diagonal one by one, and rest everything is zero, right? So this is something it's going to work. Let's say you have two different, even we will look around this in our Spark also, and I'll tell you a little bit of, advanced transformation of data. So there, this NumPy is actually help, making the data into, when let's suppose the data that are not into some columnar form, right? some certain, text form, and you wanted to convert into kind of into numbers. So there, these packages and numpys and all everything come into the picture, where because we need to do some mathematical transformation of data. So that's why it is being introduced. So yeah, like we are talking about pandas. You have any question what we have discussed here? Anyone?
No, thank you. Please continue.
Moving forward, I was telling you about some basics of uh, pandas. Yeah, so first of all, Pandas is one of the most amazing package for transforming data, looking into the data. So data, Pandas are majorly being used or help us as a data structure, a data munging tool, data, like you can say that complete data of reshaping, merging, sorting, slicing, aggregation, creating a data frame, structuring the data. That is how pandas actually help us. Okay, so pandas, are kind of built on the top of NumPy, SciPy, and it's a data analysis library. It will allow you to do ETL, analyze the data, look into the data, reshaping it, munging it, multiple things you can do that. So complete transformation of data is possible with Python pandas package. So it is one of the most used package in on Spark also, and because Python PySpark also taken some replication of their PySpark from data frame, and the data frame that's we actually going to calculate in pandas as well. So let me just quickly introduce here. Python, the very first feature of Python is Python allow you to do data structure. When I say data structure, so the very first, you can do multiple things. You can structure the data, you can calculate, reshape the data, you can slice, dice, multiple things with the data. But first feature I'm telling you is their data structure. Okay, so it's allow you to do data structure, and Python pandas can do three types of data structuring. Okay, there are three types of data structuring with pandas. The very first is the one dimensional. Okay, one dimensional. So the one dimensional data structure happen, when we have one dimension data, it's happening using pandas series, right? When you have two dimension data, then it's actually do this with pandas data frame. Okay, and when we have a three-dimensional data, okay, when we have a three-dimensional data, for this, we have pandas panel. But since we are not supposed to gonna use pandas panel, there is no requirement. We don't have any vectorized 3D data. So we will be discussing a bit on data frame and data series. Okay, good enough. So let me just show you how we import pandas. So again, we import pandas like this, and pandas as PD I'm taking up. And let's say if I have a one-dimensional data, so data is like this. We have 1, 2, 3, 4, 5. So it's a one-dimensional data, right? We have only one dimension. So how we structure this one-dimension data using pandas series? Let's have a look here. So here I will be doing, PD dot series and this X. Now when I print this X, please have a look. So you can see that the pandas is structured the data. It's a one dimension data. Okay. If I just show you the dimension, it's a one dimension. Oh, I will show you the n dimension. Great. Here you can see that it is a one dimensional data right now. But what is this? This 0, 1, 2, 3, 4. It's an index that it is showing us in an index because it's a structured data. It's showing us in an indexed form. Okay. So either you can define your own index, it's automatically taking its their own index. You can define from your defined, area 1, 2, 3, 4, 5. You can see that now the data has been structured into this way. Now, if I want index should be like this one, like the A, then B, C, D, right? So this is the data structure is something like what happened? 1, 2, 3, 4.
E is missing.
So you can see that the structured data is here, right? This is how we create it. Now you can also create, pandas series using dictionary, like we have created using list. Let's say I have a dictionary. Okay, this dictionary do have some values like, uh, you know, let's say we have A values is 1, B values is 2, C values is 3, right? Now, when I do PD dot series of D, so what will happen? What will happen? You can say that the dictionaries, uh, you know, like the dictionaries key value has been taken as a index here. Can you see this? Yeah. And the values has been taken as their values, right? So it's take the data of keys like this. And let's suppose if I define my own dictionary as well as what will happen? What will happen if I define my own index? So let's say I have defined the index like this. We have A, we have B, and we have D, and we have E. Yeah, let's have a look. So what will happen? Since it going to take the data available according to the index. So A is available, so it has taken the data into 1.0. 2 is available, so it can be 2.0. D is not there, so it's taken not a null, means it does not understand what kind of value it is. So it has taken not a null. It could be float, anything. So that's why it could be E is not there, it has taken not a null value. Got the point? So this is how the series looks like.
And it is omitting C.
Yeah, it will omit
It's omitting C.
because it's not available inside this.
Okay.
Moving forward. Okay. Just yeah, this is how this series is that. Now let's talk about the two-dimension data. Two-dimension data of pandas. So pandas two-dimension data has been creating using data frame. Yeah. So let's suppose I have a data in which on a website how many users are visiting my on daily basis website. So it's like this. So here let's say on day 1, so I'm taking two-dimension data 2, 3, 4, and then 5, and then okay, 5 is okay. Then on daily basis how many visitors are there? Yeah, so on daily basis, let's say call we have, 100 visitors, 200 on second day, 300, 400, and then 500. And how many people are getting bounced from my website? Let's say we are making this data as well as, let's say 2, 5, 7, 8, 9, 3, 4, 5. 5, yeah. So here, let's say if I wanted to convert into a data frame, so how it will look like. So I will be calling PD, df equal to PD dot data frame web and df. So here you can see that here it is the data with us. Okay, this is the data with us in which the rows has been, like the key value has been taken as their values, and this has been taken as their column name. Yeah, and if you wanted to define your own index, you can also do that. So that index has been updated accordingly, right? So this is what about pandas basics of how to create a pandas data frame. So can you just quickly create a data frame related, just quickly type down this data frame. So after that, once you create a data frame, it's a two-dimensional data frame, right? Now, let me just show you something. There are certain, stuff for transformation and multiple things is available inside Pandas. Like the very first I will, if I tell you, is let's say if I just wanted to print the initial certain columns, okay, with rows as well. So there is a function in this that df dot head, the data frame that we have. And if I mention the initial two rows I wanted to, print here, it's going to print for me. Similarly, if I wanted to print from tail, I can do that, it will print for me, right? The amazing stuff is like there are functions that will directly going to analyze the data and do descriptive analytics like df dot describe. So when we do this, it will do the complete descriptive statistics of data. If it is visible for you, you can see that the data is something like this way. It is counted the minimum maximum of all the rows, all the columns, and it has found it find like how many five values are there. Standard deviation is this, minimum is this, the first quartile, second quartile, and third quartile. Okay, this is the describe. And apart from that, there are functions like data info. This will let you know like what are the types of data available inside this. Like say day, day is a integer 64 and there is no null value. Can you see that? And how much memory it's using, it's also going to display for you. It's a pandas code data frame. The type is pandas code data frame. Yeah. So these basic information you will get around the data here, right? Now, let's say if you wanted to convert the data or you have a data that is, around, you wanted to convert or access this data into form of other tables, like into HTML form, or in is, let's suppose you wanted to take into the SQL data frame, SQL table, or if you wanted to convert into CSV file. So you can do this data that you have created into that. So let's say if I wanted to convert this data into Excel or CSV, so I will write df.to CSV and I will name this, let's say call, like lab cop1 dot CSV extension. And once I download, once I run this file, this has been saved. This data has been saved. So if you see that here, if I show you in that location, it has been downloaded. Uh, what is that? Yeah, can you see this in CSV format?
Yeah.
And either you can download this. Yeah. So this is something you can use it. Here you can actually download. Now, apart from that, let's say there is a way you can actually read the data. So how you actually going to read a data, that is also something we're going to understand. So let's suppose you have a data here. This is something we have. This is the data here. Let's suppose you wanted to read from your certain location, from certain location. So for that, we need to put the location. Otherwise, we can map all our data inside this folder only, means your C folder only. Here, all your data should be here only. Okay. Otherwise, you can actually access from any location within your computer. That's not a problem. But let's say if your data is here, let's say if you wanted to read the data that's lab cop is available inside that directory only. So then you can do read the data into like this. So pd dot read CSV and the data that you have, this one. Yeah, this is something you have read. But the data, if you have from any certain location, like I have a few datas with me, that I can actually read. So let's say I have a data that's I'm going to read, let's say called pd dot read CSV, and this CSV data is available inside certain location, let's suppose. So let's say if I have a data that's downloaded over here in my, downloaded folder, I'll be showing you. Here in downloads folder, I have some certain data.
How it is taking the default folder?
Default folder will taken because with the directory that in which the Anaconda is installed. If that is, if you can actually, I'll show you. See, let's say this is the directory. So in home, either you upload any data inside here, upload here in this location. So this directory is here. So if you go into this PC and in this Anaconda program file users, in users, ad, admin, here this is your directory where all your data is here. Can you see that? Your
Okay,
IP bandwidth file, everything will be installed inside this. So if the data consists inside this folder, you can directly read it. Okay, like this is one of my data, and like this is the one data. I'm just showing you, like, in case you are reading from outside. Let's say one data is available here on my desktop. Okay, so this is the data. I just go into properties and just copy this location, and I will be going to mention this location inside here, and I will just put the location inside here and slash. And another thing is that the name of file. The name of file is this diabetes1.csv. So again, after slash, just copy this and then dot CSV. So there is one thing, there should be an option where when you print this, you will get your data, but sometimes it's not. Why? Because what the problem you get, because sometimes you got a Unicode error. Okay, Unicode error because code, the kind of access from the in web UI from the location, sometimes it gets some access problem. So for get the admin access and codec problem, you can use double slash. So it try to. So now you can see that when I do double slash, the data, whatever available over there, has been taken up here. Yeah.
Same case with rating as well, right? You can give the complete path.
Yeah.
Contains the default directory.
Yeah.
Okay.
So that is how you can read the data. Now, if you wanted to just look around this data, so if I just print how many, the shape of this data, that's a data dot shape. The shape is 768 rows and 9 columns, right? This data consists 768 rows and 9 columns. Okay. And apart from that, what are the different data types I have available inside this? Like what all columns are indicating. So for this, let me just print first all columns. So these are the columns inside this available, like pregnancy, glucose, blood pressure, skin thickness, insulin level, BMI, diabetes pedigree function, age, outcomes. So these are certain columns that is available inside this. Yeah.
That is the first row in Excel.
Yeah.
That is the first row in Excel.
No, yeah. So it will print all the columns for us.
It's taking data from first row, right? The column name.
Yeah. So it will print all the columns by taking without delimiter. It is printing after delimiter. It is printing all the columns to us. Yeah. Moving forward, let's suppose if you wanted to, as I mentioned, if you wanted to look around the data, that is to understand the descriptive statistics. So you can do data dot describe, and you can see the. Yeah. So this is the descriptive statistics of data. It's have 768 rows and something like that. So here you will get all the stuffs. You can print the data types, data dot D types. Okay. Types. So once you print data dot D types, this is the data, whole data with us, and 64 float, something like this. This is the whole data with around us. Yeah. And apart from that, as I mentioned already, info, columns. Now, let's say if you wanted to access a particular column, here, if you wanted to access a particular column, let's say pregnancy and glucose. So there is one way you can do like this way. So let's say axis of slicing column, you can say that. So let's say you have a data and you wanted to print the, you know, specific column name. So here, here once you print, it will print all the column, uh, the pregnancies, all the values. Yeah. But let's say if you want to print more than one values, so then you can do slide like that. And the second column is, let's say, glucose. So I'll just mention. Can you see that? Because two column has been printed. Now, let's say I want to print the initial 10 entries. So I can go here and just slice it up. The initial 10 entries has been printed. Yeah. And that is one way to access the data. The one way is by accessing the values like this. The another way is by integer location. Integer location. So integer location is what? Let's say while I'm reading the data, pregnancy is on 0th position. Glucose is on first position. Blood pressure is on first, third, second position, like that. So you know Python slicing, all of you, right? Hello?
Yes.
Some of us do.
Yes.
Python slicing is, let's say, we had a list and I wanted to access a specific element. Like if I have 2, 3, 4, 5, 6, I wanted to access the last element. So I will put -1, it will print the last element for me. So, and if I wanted to print the into a specific element, let's say I wanted to access the 0th element, it will print the 0th element, that is 2. If I wanted to print 0 till 2, so it will print 0 till 2 means 0 means 2. The second one is 3. One is 1, 3, and till 1 before it will print. So that's how it's printed. So this is called Python slicing. Now the same can be applied here. So here, if we have an integer location, okay. So if I wanted to access this into certain integer location, like I'll show you. Let's say I have a data, and I will mention the data.ilog. I wanted to print whole rows, the complete rows. So the complete rows I wanted to print of any specific column. So what are the specific column is? Let's say I wanted to print the specific column called 0, 2, 3, 4. So when I do this, you see that I have a specific column, let's say called pregnancy. The second one is blood pressure, skin thickness, insulin. All has been printed. What I want, all the rows of it. So column is for all the rows. Did you get it?
If you want to print the top 10 rows,
What?
if you use column, it is printing all rows.
Yeah.
I want to print top 10 rows.
If you wanted to print only initial 10 rows, then you can do one thing. Just print here, and from here, let's say from 0 colon 10. Can you see that?
Okay.
Yeah.
ILOC is full form for identity location,
Which one? ILOC, integer location.
integer location.
Then let's say if I wanted to print any specific, let's say I wanted to specific that I want a 0th row and 5th rows of 0th column and 5th column. So how are we going to print this? Is, let's say I wanted to have a 0th, 1 of 0th, 1. Okay, read the data, and I want you to try these two things, integer location, because sometimes accessing sometimes got confused. So I want all of you just quickly run it. And if you are all able to understand what we are doing, can I get a quick Y in the chat box? And if you don't, if anywhere any problem, please type. I will able to explain you. It's here. Then how we can explore the data, how we can actually print the data type, how we can print kind of like how to access the data. Let's say if I wanted to print any specific column, here is specific column. Then we will be discussing the grouping by the data. I mean, based on certain conditions, I will be going to discuss. Then I will be going to discuss how to, rank the functions and other stuff, filter the data, we'll be talking about slicing, null values, data cleaning kind of thing. Like I have told you the location methods, iloc methods. This is the location methods, and this is all the location techniques that you can actually do that. So yeah, then data sorting and all those stuff.
Dipesh, do we have something on reading the data from S3 bucket, connecting to S3 bucket and reading the CSV files or any other files from the S3 bucket?
What? Yeah, that we
Accessing
will be
the
doing on
That will
Databricks.
be doing, right? Oh.
We will be mounting the data from S3. Even if you wanted to use on Jupyter, for this there is a package called Boto. Have you heard about this package?
So butterfly.
Yeah. So with the help of Boto, you need to install the Boto, then you need to mount your S3 bucket here, then you need to go to the IAM access. That IAM access, you will have to access the data from those where, and that you will, once you put this, then you will able to access the data available inside your S3 as well as.
So are we having that exercise also in the session?
Have exercise in our Databricks session, not here in Jupyter. We're discussing the basics of, Pandas. Have you accessed that data? All of you? Are you able to read?
Yes. Yes.
Yes.
Good enough. So now once you do that, see the further is, let's say I mentioned there is a one important technique in Pandas that's called group by. Group by is what? So as I'm mentioning here, just group by. So yeah. So basically in Python, Pandas, group by allow you to access the data or split the data groups based on certain conditions. Like in SQL, we will able to do that. Similarly, we can do that in Pandas. We can access the data based on certain conditions. Merge the data based on certain conditions, access the data based on certain conditions. In dplyr, we in R we use this. Similarly, we can do that in Python pandas as well as. So how group by will help us? If you can see that we have a condition of let's suppose we had a data. Okay, I want to group by based on rank out of the total data. So the all data will be based on rank, and then I can find the mean of it. So whatever the data we will be split based on, and then based on that I can do some calculation. Like I will show you in our data. So here, let's say I have a data dot group by, okay, and based on conditions like pregnancies and pregnancies I have taken up. Let's say I wanted to do this based on two things, pregnancies and let's say one more data column that's called BMI. I wanted to count. So you can see that I wanted to count the BMI count based on this pregnancies over here. So here you can see that this is what based on 0 month of pregnancy, the count of the total is this one. Okay. And like similarly, you can talk about any one of this specific stuff. Are you getting my point? The group by? Cool enough. Then like we have an aggregation technique, aggregation in pandas. So let's say I wanted to find out on the same, instead of this, I wanted to do multiple things, let's say I wanted to find out a few things. I wanted to talk about here the aggregation, not just count, aggregation of few functions. So I wanted to find out the sum of this. Also, I want to check the skewness. You know the skewness in data? Hello?
Yes, Dipesh.
Yeah. So you can see that I had taken what happened? Aggregation, sorry, I have not taken into the list because. So you can run multiple function on data using aggregation function. Yeah. So this is what the aggregation technique. Then, yeah, here. Then we talk about aggregations and all, then you can actually, we have did, we can group by based on doing short equal to false, and then we find out based on rank and salary. This is how the output will come. Even though you can do filtering of data. So filtration is also one of the technique that is available inside here. And that how we do filtration is simple, like we have a data, and based on our data, so we can either define which data. So I'm taking this data called pregnancy, and here based on, I'm checking how many pregnancies of data are available here. So where it is 4, so that is how you can do filtration of data. So data filtration is here. This is called data filtration. Now, moving forward, if we have to check whether there is a null value or not. So let's say if I'm talking about data cleaning now. So data cleaning is like, let's say I want to check whether the data is available, any null values or not. So let's say if there is null value, we can check by checking is null, and I can do the sum as well. So if there is a data is available, let's say some null value. So is null. Yeah. Correct. So we have created one data frame, one data series, no? What's name?
This DF.
This SS. So if I check SS dot is null dot, you can see that there are two values where there is a null value. And if I want to fill that, so SS dot fill the null value using some certain values, I can fill anything inside that. So you can see that instead of there, I have filled some values, right? Okay. So that is something we have done. Now I wanted to give you a small problem statement. and I wanted to give you some time, let's say call 10-15 minutes. I want you to just quickly look around this and do all the stuff that we have done over it. So just a second, I'm just sharing you a file. Yeah, and this is a matches.csv. Okay, in this, if you can find out, there are so much of information about the IPL matches. Yeah, this is the data. Yeah. So here, this is the problem, and you can see that there is season, city, date, which team is there. Okay, team, toss winner. I want to evaluate the data. I wanted to ask you just evaluate the data and do some certain questions that I'm supposed to gonna ask you. So what are the questions are? Let me just going to, like, okay. So yeah, moving further. Here, as I given the problem statement on the data on the matches is, yeah. So these are the problem statement that has been given to you, in which I have, like this is the data that we have. So as you know, the shape of data is the shape is this one. So 636 rows and 18 columns. And if I just quickly willing to describe the data, this is the CSC. Yeah, this is the data we have. And moving further, as I mentioned to you guys that, like, we wanted to know like what are the columns, how many seasons we have, how many, how much data we have got in the data set. So even we can understand there are 636 rows, even though there are multiple way you can find this, like, like by checking the matches print, uh,
Number of IDs.
dot. I can either you can calculate the ID also, okay, and you can find out the max of that ID. What is that? D dot. Yeah, that is where you can do that. Or there are n number by finding the length of anything, by multiple way you can do that, right? Now the next question that has been asked, how many seasons we have got in the data set? So by applying sets, by using sets, you can do that. How you have done, guys?
You can use group by as well, right?
That we can do that, and also there is a function in this that's called unique. So by doing that, you can do that as season dot unique. Okay, so unique will give you what all the different, oh, what I'm doing. Yeah, so you can see that this is giving me all the unique seasons available. That is 2017, 8, 9, 16, 15, everything is there, right? Then by using the length of this, there are 10 different unique seasons are there. So we can get the output, or even you can do group by and all. That is also one of it, right? So that is one thing. Then moving further, like the next question that is being asked is, which team had maximum number of runs? Which team had won by maximum number of runs? So this is this can be done by n number of ways. Yeah. So there are many functions in Python, pandas, that you can do that, or you can do by group by. There are multiple way you can do that. Let me tell you one or two way. Okay. So one way is this, by talking about d dot and largest, and you know we wanted to find out the top one team who win by runs maximum. So here we have win. What's the column name? Win by runs. Win by runs. Okay. This is win by runs, and I just wanted to get the winner. Yeah, are you getting the same output? Hello.
Yeah, I
Or
used max there, but
yeah,
yeah, means I didn't use this method, but using max and then printed out the location.
correct, correct. Another way that you can do is integer location. That is your column. Either you can print the integer location or just win by runs. Win by runs, and there is a function called IDX max, means it will print the ID of maximum of the whole ID, means whole row it will print around that. So let me show you this function that is called IDX max. Okay. So when you print the IDX max, it is going to print the whole row in which the maximum was there. So the maximum is win by runs is 146. So it has printed the whole rows, and then you can slice the winner. Yeah. That is also you can do that. Now, similarly, you can the same way we have done this win by runs. Similarly, we have win by wickets. Okay, instead of this win by, I will mention wickets. So we got Kolkata Knight Rider, right? This is the output you're getting. Good enough. Moving forward, we had another question that is, what is the next question? Which team had won by closest margin? When we say closest margin, what is the meaning of that? Means a team won, but the margin between a winner runs and win by runs, okay, uh, should be very less. Okay, should be very less. So for that, I can write something like this. So how you have done this problem statement?
By using win by runs, taking the minimum.
Okay. So D dot I log, and then see, I'm taking this data that is again win win by runs. Okay. Now, okay. See, I wanted to put a condition. A condition is that the condition is, the win by runs should be greater than 1 or equal to 1. Are you getting my point? Means minimum run should be what? At least one run difference should be there. Hello?
Yeah.
At least one run difference should be there. So that's why I'm making this condition. Either we can do this condition like this. So here, D is in a condition where I can put here, either I put here greater than equal to 1, or in this you can write dot GE1. GE means greater than equal to 1. Okay. And I am going to find win by run IDX minimum. So I'm printing the whole ID minimum. Okay. Just a second. IDX minimum. Yeah. And here is the data that we have. So win by runs, that is IDX minimum. Okay. That's we are getting Mumbai Indians. It is printing the first one, and we can find out the winner. Got it?
Can we also do it by, similar way?
Mhm.
And take the lesser number of runs and not equal to 0, apply not equal to 0.
Not equal to 0.
Take the lowest margin, but the margin should not be 0.
Yeah, that way also you can do that. That's not a problem. So that is one method. Similarly, you can do by, find out the n smallest, like we find out the n largest. There is a way you can write n smallest, and that's how you will find out the win by wickets, and then, like that's how you can do that. So that is the way IDX minimum way you can find out, do that, right? Now, we have similarly, like we find out the wicket, similarly you can find out the winner, you find out of runs, similarly you can find out by wicket as well as, correct? Now, the next question, it is indicating related to which team had won by minimum wickets. Okay, that we can do that. Which season had most number of matches? How you have done, guys?
We can group by using seasons and then print out like count IDs and then
Take the maximum.
Yeah, that is one way. You do this. You group by and then you print that. Another way is I'll show you. That is your data dot your sorry season. Okay, and there is a function that's called value counts. Okay, so once I do value counts, you can see that it is giving us that, like this 2013, which season? 2013 have the maximum number of
Matches.
matches, right? And we can take it from there as well as, okay, that's how you can print. And yeah,
By default, this function printing the values in the descending order.
correct, in a short. Okay. And like when I would have show you the right now, I'm not, know about Seaborn. So the same thing with the visualization, there is a direct function of Seaborn. Okay, and that will allow you to print this as a, like as a count plot. So Sanas dot, when I'll show you this. So let's say you have taken this uh, as a and data equal to the
What is PLT?
just a second. From macro. Let's see. Can you see that? So it's visualizing the data 2013 have the maximum number of matches.
You're displaying PLT. One second. You're displaying PLT,
Yeah.
but the value is in SNS.
No, I'll just explain you. When I'll come in the second half, I'll discuss this thing.
Okay.
Yeah. Yeah. So I'm just telling you, like with the help of visualizations, also these things looks more easier and looks to give you better idea. Even in our Databricks also, there is a integrated dashboards where you can do visualizations over there. So we will explore that also. We'll just look around there. Yeah. So that is what. Now the next questions you had is which season had the most number? Oh, sorry, which
IPL team is
IPL
more
team is more
successful.
successful? So how you can find out? Of course, those who have win the matches maximum is the more successful one, right? So we can find out this way: D dot winner value. Yeah. So you can see that the maximum number of matches Mumbai Indians have won. So Mumbai Indians is the most successful team in.
Can we slightly twist that question? Like, can we take the maximum winner as the uh, team which won most number of matches, like percentile wise?
Percentile while.
Yeah. That's
Okay.
how we decide more successful.
Yeah, we can. Then we need to create a conditions accordingly. No, we can do that.
Can we try?
Okay. So you want that this, like, should show as well as the percentage, like which team has won how much percentage.
Yeah. So when you asked that question, I figured. I mean, I thought it's like we have to take the number of winning the matches divided by number of matches played
So then the
and take the maximum value.
total number of matches we need to take.
Yeah.
Um,
For that, we need to look at two columns here. One is team 1 and team 2.
yeah. So we can do one thing. To print percentage, see, one way is that we can directly use, with the help of, pie chart. With the help of pie chart, we can display this. There is a technique by which we can show that. Okay, that anyways I'm supposed to gonna tell you. And another way is that I will first consider this as a kind of, take this as a one list of these teams that we have taken and these values, right? Then I will calculate the total, or maybe I can take the number of at that the value, and then I will, like then I can define this, like which team had, the maximum percentage winners.
Now, the challenge is how do you identify how many matches each team played from that Excel?
Each team had played. We can count that, no? Like,
Using two columns.
yeah. So let's say we have this values in which, let's say I have taken here, let's say this is the data we have. So we, let's say, take as a success, more success, like more, let's name it S. Okay. So this is the data we have, right? Now, if I wanted to find out the more successful team, then it will be going to be S dot IDX max, right? So I must have this data, this Mumbai Indians there, right? Now I wanted to know the percentage out of the data. So like how can I do that? So win percentage will be equal to this S dot max divided by S dot max multiplied by 100. Yeah. So
Deepesh, I think what I'm asking is you have team one and team two, right?
Mhm,
So how can you, if so let's say I'm looking for Mumbai Indians.
mhm.
So how can you count the number of times the Mumbai appeared in team one column and team two column?
How many times Mumbai Indians appeared?
Appeared in team one and team two both columns.
Team one and two into both columns. This is the data we have. Okay. So this is just a team one, like the matches between both the two team, right? Matches between the two team. Okay. Now, in this case, let's say you wanted to what you were thinking about, like team one and two, between them there is a match happen. Okay. So there should be one certain winner. So out of these two matches, there is a winner.
Mhm.
Okay. And the question is which team had won by maximum time. So we can directly get the winner over there, like which team had won by maximum. That we find out IDX max, and that's we got Mumbai Indians. Okay. So
Now,
this is what we have. Now we can calculate based on the total number of matches happen. So how we get to know what is the total number of matches happen? We already understood now by using understanding like this is the in all the seasons. Okay. So in all the seasons, we have total number of matches 600 and there we got.
but that is not
Yeah,
Mumbai Indians did not play all those matches, right?
or not total matches, I guess, but only the matches played by Mumbai Indians.
Mumbai Indians.
Either in team one or team two, like basically the winner of like winner to 92 divided by total matches played by Mumbai Indians, and that too for each team, like those percentage, right? I guess we
That
got.
will give you winning percentage.
Yeah. Yeah. That we can find out. Yeah. Mm.
Now, can we do that logic here? That's what I'm asking.
You can do that. Um, just quickly explain me if I understood it right. So we have two teams, team one, team two, we have winner. You wanted to understand the matches between Mumbai Indians with any other team. Out of that, you wanted to find the percentage of winner, right?
Correct.
Okay. So for this, we need to take team one and team two. Okay, this is the data. Then what we need to do that, okay, we need to check, okay, there is a character verification we'll do. For this, we need to do a kind of a filtration of data. Okay, that is, let's say out of the data, let's say data equal to, we need to create our own data in which d dot, what do we say? The function name that is, you know, just a second. Team one, and team two, that is in character, something in pandas, there is a function called finding character. Not able to recall the function. Checking character pandas. Just a second. Not able to recall the exact function name. Just a second.
That's okay, Deepesh. We can come back to this later.
Okay.
We can move on.
So basically there is a function that's called just to check the specific character. And even though what we can do that is we can check the uppercase and lowercase as well as, because sometimes it is possible Mumbai Indians are written into capital M and U, that's something like that. And let me just quickly
Is that something str underscore contains or
contains,
str
yeah,
dot
yeah.
contains?
Sorry, yeah, I was not str.contain. So when I actually go to check, if the values are contained over there, str.contains, okay. So that value, once I put into that, okay, then we will have a filter of our data. First of all, the whole filtration of data will be there. And once the filtration of data we got to know, then accordingly on those data, this is what I'm talking about here. The type data.type str contain earthquake. Okay. So where in this I can put data dot like in our team one dot str dot contains Mumbai Indians. Okay. And that is how I will get to know if any one of the team having play happen between Mumbai Indians or not. And then I can find out between them. Got to know?
Yeah.
Yeah. Okay. So yeah, I mean this is this the idea between them. So what we got to understand is, we have done some basics of, there are so many functions of pandas, there are varieties of functions and you can put multiple logic. It's all about the practice, like how, we cannot recall all the functions, but rather, there is an option whenever you have a function, you wanted to apply a function. So this allow you to give all the functions here. Yeah. This allow you to give all the function. I'll show you something. So I have a page where all the function of pandas are mentioned, pandas all functions. So that you can actually go through. Yeah. So you can see that every single functions, either it's to import pandas and check the version, how to get the item not to both series and A and B, how to get 25% median mode, everything convert into series to string. Every single function's been discussed in this codebook. So everything around that is there. Let's say if you wanted to find out a union between the data sets, you want to join between the data set, you want to check the percentile, you wanted to check the anything, converting into some random values, then, like date, time, everything, text analysis, all the functions of pandas has been discussed in this notebook. So as I mentioned, we can look around some kind of a visualization at the same time. And, this visualizations is giving us an idea like how um, you know how to interpret data first of all. So for this, yeah, so to interpret the data in a better way, we have we need to understand there are multiple way you present the data. Either you are presenting the data in order to compare something, to find out distribution relationship, or you are doing composition between them. So these are the options by which you are able to confine in a better way. So this is the idea. Now look around this. Um, you know, we will going to, do multiple kinds of plot with that. So let me set up my, just a second now. There are multiple packages for visualizations like Matplotlib, Pandas visualization, Seaborn, ggplot, Plotly. There are varieties of visualization techniques. Okay. And we supposed to gonna talk one of the visualization first. So the base package on which all the visualization libraries are there, okay, is Matplotlib. Okay, so Matplotlib is the base library for any data visualization kind of thing, and when we visualize the data, or even though any third party that you see visualization is happening, beside that, the programming that has been reconstructed is Matplotlib, right? So Matplotlib is the base library, right? Anybody have ever worked upon Matplotlib before that? Hello? Yes? Few of them? Good? Or maybe. So let me just quickly tell you like how Matplotlib is useful and how this can do a lot of things. So for this, you need to first import the package that is called import matplotlib dot pyplot as PLT. So in import Matplotlib have a lot of things. We have multiple stuff we can do that. Inside this for visualization charts and all, we have pyplot, and I imported it as a PLT. So once I do this, see how it's work basically. It's work on coordinates. So if you have any coordinates, you can do the visualization. So you have any coordinates, let's say call 1, 2, 3, and in X, Y coordinates we have, let's say again 1, 2, 3, 4, 5. you know so when you do this, let's say I'm doing a simple line plot. So for simple line plot from PLT, I'm taking a line plot. So here you can see that when I did this, uh, yeah, so simple line plot has been constructed, right? If you want to see where I have mentioned this, uh, so this has been constructed. Now you can see that. Yeah. So these are the points where this 1 1 is there, 2 2 is there, 3 3 is there, 4 4 is here, like that. And you can make anything out of this. And if you have any data, the data can be taken up accordingly and you can visualize it. So this is a simple line plot, right? And apart from that, let's say instead of this, let's say I have multiple other line plots also. Like I just make a coordinates for you, just a second. So let's say we have 2 2 and 3 4. Then we have yeah, see. Can you see this? I made a square box using coordinates only, right? And I'll show you some more thing on the top of it. So PLT dot like I wanted to increase the coordinates on which it will just going to show us. What is that? X lim. So it will increase the boundary. So 0 to, let's say, call 5 I have. And similarly, I can mention PLT dot ylim also 0, 5. So here it is. The limit has been increased of this. Okay. And I'm just showing you something like all functions quickly. Here I have taken one more x1, y1, and here I have taken plt dot plot, and this is x1, y1, comma, here I mentioned marker equal to this asterisk, right? And yeah, I mean, you can see that there are two. Oh, sorry. I just need to make it some changes. 3, 3, 3, 5, and 5, 5, 5, 3, 3. Let me do this. Yeah, just the basic changes. So you can see that this has been created accordingly, and then just a quick label equal to 1. Yeah, and you can change even color. Let's say this, Yeah, can you see that? And if you want to label like X label, Y label, you want to write anything, you can do that. And one more thing, see, there is a yeah. So here, let's say so some background style.use from matplotlib and matplotlib imported style.use. Oh, I have not run this. Yeah, the background has been changed. So this is what about, some basics of it. And if I want to label the legends, so plt dot legends. You see that the legend has been printed to make you understand what this meaning of that. So the label what we have given is printed as a legend. Yeah. Similarly, you can do bar plot, plt dot bar x comma y. So you can see that this is the bar plot. Correct. So you should have some certain data for this. Like in our case, let's say if the data we have is called data dot what web day comma web visitors. Can you see that? Hello.
Yes,
I
Nitin.
can see it.
Yes.
And, this is what we have, and we can do multiple on the top of it. You can increase the height. You can increase the width. That's not just I'm telling you like how it's look like. Similarly, this is a bar plot. Then we have plt dot scatter. Then we have similarly we can do the same for this. Let's say I wanted to print this scatter plot. This is scatter plot, correct? So scatter plot can be done. Yeah. And yeah, the important one is like this. So let's say we have to, we have certain data, so basically, let's say I have a data of my, in a day, what all the things I do, activity, let's say call the activity. So activity is what they call, I sleep, eat, work, or you can say, what we say, you know, sleep, right? Now I have some basic values with that. So the values are like this. Let's say call I sleep for an 7 hours, eat 1 hours, work, let's say call 8 hours, late 2 hours, anything. Now if I wanted to do a pie plot, so I will write plt.py and in plt.py first the values and the labels that I wanted to use. So label equal to activity. Labels is activity. So can you see that here? We got this pie plot. Let me just make it more insightful. So here I'm using that to start angle equal to 90 degree. And one more thing that's called auto PCT. So automatically it should print the percentage. Auto PCT Autopacity is 10%, 1.1 at 10%. Yeah, so just a second. Can you please write it down, all of you?
Dipesh, what is this F signifies here? 1.1 percentage
It will print the percentage with
format?
fraction, with fraction.
Oh, okay.
Yeah. Hello, yeah, they're done. So here, like if it's showing like this, PLT dot show. So that is how it is going to display in this format. Better now? Okay, so what I want from you is the diabetes data I have given to you guys, right? I want you to quickly just access that data. You have this data, right? Sorry, I have shared both of them. So I want you now to categorize which team won maximum time in a form of, like pie plot. How many times which team have won? Accordingly, I want this pie plot. Understood the question? Hello.
Can you please repeat?
I want the matches data I have given, right? The one you have done little earlier, just now, before a break.
Yeah.
So in which there was a last question in which second last question we have asked, which team had won by, which team have, like we have, which team is the maximum seasons happened, right? And so I want two different pie chart, one pie chart based on seasons. Let's say if Mumbai Indian, if 2013 have 15 seasons, 16 seasons like that. So a pie chart of all the stuff, you know. And second, which team won how many times in a form of pie chart. Understood?
Yes.
Please do that.
Yes.
This is your.
So the issue is in that decimal value 1.1 F.
Just as, oh, yeah, sorry. It should be in a quote, right? I forgot. Can you see that? Got it? This is what we want. So the maximum time won by Mumbai Indians and Chennai Super King. Like this. Did you understand the logic as well as? Did you? Or you want me to explain? So basically what I've done here is I've taken value counts. Okay. So when we do value counts, we have already done on top, right? We got index and their specific values. So winner, like how many times which wins. Okay. Then, you know, like here, if I show you here, when I show you this DF, this is how it's look like, right? So in index, I have taken this, and this is in S, I have taken this values. For the point, these are the values of this. So when I taken the values of this, you know, here, and then out of which a 10% is printed. Otherwise, you could have done by using group by or something like that. So as I mentioned, this is how you can actually do kind of a visualizations with, you know, like the with Matplotlib, and not just, you know, a basic visualization, but more than that. Like if you want to have you know, further more visualizations, you can actually do that. And you know, like this is just a basic visualization technique using Matplotlib. There are so many other things you can do that, like histogram. Then we have a, where is that? So as I mentioned here, you can do you know, this a subplot where multiple plots can be plotted on multiple axes. Then you can do histogram. Histogram is like the splt.histogram. Then you can bar chart. I already told you. Box plot. You know box plot. Anyone here? What it's used for? So box plot is something being used to detect the outliers. Okay. It allow you to detect the outliers, and it will allow you to print multiple visualization stuff on the top of it. Okay. So multiple visualization stuff, when I say like it's print the quartiles, it print the, you know, minimum, maximum, or interquartile range. So it spread the data throughout. Like you can see that we have a value, let's say called 1, 2, 3, 4, 5, 6, 7, 7, 8, 8, 9, 10, 21. So it printed the minimum value and the maximum value. And you know, as you can see that minimum, the first quartile should be here, the third quartile here, and the maximum. If the minimum is very on the top, okay, the minimum is here, and it is spreading the data like this, so means we can understand there is an outlier. What is outlier? Outlier is something that is very odd to the rest remaining data. Either it is very high or very low. So, you know, you can see that this is the median, and this is the first quartile, third quartile, and between them this is the IQ or interquartile range. So you can print box plot as well as then pie chart. I already told you. Then there is a heat map. Heat map, I'll just tell you. We can print these kind of maps with that. Now, one package related to advanced pandas, NumPy, Matplotlib, assimilated in one package, that is called Seaborn. Okay, so Seaborn is one another package that is also very advanced and like you have a lot of thing inside that. Like I'll show you. Seaborn is also called as statistical plotting. You know, statistical plotting. What is statistical plotting? See, right now when I asked you to plot based on the maximum, I want you to plot this or maybe values count when I show you. So if you remember like this visualization when I with C1 I told you. So here what I have done, I just put a count plot, means already a function is prepared related to count and we just need to put some values. But if you do using Matplotlib, you need to first find out the values count and again do the same thing. Are you getting my point? Yeah. So it's have all the statistical plotting, advanced statistical plotting. So like, so and not just this, but there are so many datas are sample datas are also there just to reiterate the process. Then you can do, let's say you wanted to do a linear regression plot. You want to see how your datas are flowing. Okay. So that kind of plotting are there. So like I show you, let's say I have a data, I'm importing C1 here, import C1 as SNS. Okay. So here I'm importing one data that's called tips. So tips have so many. So SNS Seaborn have so many data set. Like we have, I'm loading a data set here. Data. So sample data sets are available inside this. You can list all the data. So one of them is called, you can. There are so many data sets are there. One of them is called tips. And when I show you these data sets, tips dot head, this is what you can see that. So tips have total bill, tip, sex, smoker, day, time, size. So based on a in an organization in a bar or something, how many people are giving tip, what the amount of tip is given based on the gender and whether they smoker or not, day, which day, time, it was dinner or lunch, whatever it is, size of people was like that. So based on this data has been captured. Similarly, so many datas are there, right? So you can use them, and based on that you can do different kinds of plots. So like one of the plot I'm just telling you, one of the linear regression plot. Linear regression, anyone? Hello? Regression,
Yeah.
Slope of line y equal to mx plus c.
Yeah.
Yeah. So let's say you wanted to understand how the data are related to each other. Means we have x variable and y variable. What is the relationship between them? Okay, so those kinds of advanced plots are here. Like I'll show you. So here, let's say I have, I'm just plotting uh, LM plot. So oh, sorry. X, I am taking tip, and Y, I'm taking total bill, and data. These are tips. So you can see that when I just show you plt.show, it should look like this. You see that? So we have X and Y data, and this is plotted like this. Yep. And we can set the axis also, if you wish, like uh, if you wanted to set the axis. The bills, from total still define your own. Yeah, you can define your own one. Automatically it was taking the one. So with these kind of advanced plot is there. Like let me show you few more plots. What these plots are like you can do. So let's say you know, let's say I have a data that I'm going to load that is called iris data. So in this we have iris data. Yeah, iris data I'm loading, and I'm just doing SNS dot load data set iris, right? And then I'm going to show you the set. So this iris data set have few data points. Like if you see that we have, if I just tell you the values count in spaces, we have three different types of spaces of data in space. Like we have iris setosa, iris virginica, iris versicolor, these kind of different types. And then we have sepal length, sepal width, petal width, length. Now, if I want to do a categorical plotting, so if for in Seaborn, there is a categorical plotting, categorical plot. So for this categorical plot, we have two types of plot. One is strip plot and one is swarm plot. So I'll show you the strip plot first. So we have SNS dot strip plot, and strip plot we are doing based on species. Species, and then why I'm taking based on petal length, and data is our array. So I'll show you something. So you can see here how this has been taken up. Let me take this background as a white. This SNS dot set file is yeah, can you see that? So you can see that. See how this is changing. Like you know, like we have three different types of. Did you understood this data visualization? We have three categories of data, right? Now, based on the sepal petal length, I have fabricated the data. So the petal length of setosa lies between 1 to 2. Versicolous petal length lies between 3 to 5, 3 to 5.5 or something like that. Virginica is lies between 4.5 to 7. Are you getting my point? Hello?
Deepesh, could you repeat what you just said?
See, we have three types of species of data. We have setosa, virginica, versicolor. What we want, let's suppose the condition is, let's say in our tip data, we have female and male. I wanted to understand how male and female are spending their money. Okay. I want to see the kind of a visualization. Or similarly, in this species, we want to know what is the length of their petal of different species of leaves or flower. Okay. So what we have taken up, we have done a strip plot. A strip plot have three types. A strip plot we are doing based on species. It's three species we have. One is virginica, versicolor, and Setosa, versicolor, and virginica. And based on their length, it will be going to do a categorical plot. Understood?
Yeah, but how it is different from scatter plot?
In a scatter plot, you need to define everything. First you need to define for three different categories. Okay. And then for every single categories you will be plotting, and you cannot combine at a once. If you want to combine, then it will go like 1 and 1 over, it will hover it. Okay. Where in a strip plot, it is going to do a categorical plot between all the three different ones at a, just by writing in a single line.
It's like multiple plots in a single plot.
Correct.
Correct.
Yeah. And in the same way, like when, see, right now it is overlapping one by one, overlapping one by one. So if I want that it should not overlap, then I will use swarm plot. Can you see this?
Yeah.
Okay. Now one more thing I will show you. Basically, there is one amazing statistical plot that's called pair plot. Okay, that is SNS dot pair plot data equal to iris. So in pair plot, you see that it is amazing one. If you can see that here, what has happened here is all the data here, it is your data. So in which all the numerical data like sepal length, sepal width, petal length, petal width, we are plotting the data, is doing the scatter plot between every single one. What is the idea behind the scatter plot? First of all, let's understand this. So scatter plot is very useful to understand the relationship between the data. How? Who gonna tell me? What we understand with scatter plot?
How they are spread over a scale.
Let me just quickly tell you here. So basically, if there is a scatter plot, so if there is a scatter plot, so let's say if the plots are like this, see, you should first know the concept of correlation. What is correlation? Correlation, let's suppose you have a value called X and Y. So values are 2, 3, 4, 8, 9, 10, 12, let's say. So how would you check the relationship between X and Y? How would you understand? So this relationship will understand by correlation. Correlation. What is correlation? Correlation is nothing but it's a degree of regression. Degree of regression. What is regression? Regression is again the relationship between two variables, X and Y, both at one is dependent, one is a dependent variable, is called a regression. Okay. So let's suppose you have any value. If you want to know the relationship between X and Y, whether while it is, we are making, when somebody is increasing, somebody is decreasing like that, what is the relationship between them? For this, we find out correlation. And correlation values lies between minus 1 to 1, right? So if the values between the correlation of X and Y is near to 0, there is a less, relationship between the data. Means there is a negative relationship between the data. There is no relationship. If the values lies between 0 and 1, that means there is a positive relation between the data. And if it is 0, means it is uncorrelated. Uncorrelated means there is not a negative or positive regression. Are you getting my point?
Yeah.
Yeah. So this is called correlation. So values lies between -1 to +1. Okay. And how do we find value? Formula of correlation is nothing but it's a covariance of xy upon standard deviation of xy. This is what the the correlation formula. But you need to just understand what the values lies between -1 to +1. Or you need to find out the correlation of all the data one by one. Else, to know the relationship between the data, the dependency between the data, when we do ETL, when we do EDA, this is very important factor we look into that. Like if there is one column, whether it is any relationship between the another column or not, Should we discard it? Should we make something? So we use this correlation very much. So for that, we first find out the correlation values between all the data, or else you do visualization. If the visualization between the data or scatter plot between the data is something like this, means if it is into this side, means right side, it's a positive correlation. If the values are like this, like the all dots making a straight line, it's a highly positive, means it is possible the correlation values is 1 here, highly positive. Got the point? If
Yeah.
the values lies like this, it's a negative correlation. Negative correlation. And if the values like this, it's a highly negative correlation. And if the values are like this, means this is uncorrelated. Are you getting my point?
There is no relation at all.
There is no relation at all, right? So now, if you are looking into the data before we actually do the ETL and all, we need to look these pointers. We need to have an understanding about the data while we are making anything. We need to have this understanding about the data. Now, in order to look into that, this pair plot is actually helping. And how your perfect data actually look like, how a better scale data look like. A perfect data or a scale data are into bell curve, right? It's a normally distributed data. Normally distributed data. Hello? Anyone knows what is normally distributed data? Yes.
Where the median is high.
No. Any guesses?
As per the normal distribution, right? So within the 2 sigma, then the range, like from the median, 1 sigma on the left and 1 sigma on the right. So it is 66.7%, and then ultimately it becomes a bell curve, right? And others, it is the center is not skewed basically.
Correct. Means when the center is not skewed, means mean is equal to median equal to mode. Okay. When this condition is there, that is a bell curve, means it's a perfectly normally distributed data, right? If it is like this, means it's a left skewed, or if it is like this, it's like this, it's a right skewed. So that is called skewness between the data. Okay. So the perfectly distributed data are also called as, like normally distributed data. Okay, that the data that is in symmetry. Okay, so this is one condition that we have, and that's why we created this pair plot. So this pair plot is resembling, in if you see that, it has taken all the 4 coordinates like sepal length, petal length, sepal width, sepal length, petal length, sepal length, petal width, sepal length. Similarly, it has taken up all the, in diagonal, it is distributing the data as per how it is distributed. So somehow I see sepal width is near to, kind of a normally distributed, kind of, right? So in diagonal, all data are showing as a distribution. Okay. And in left, it is showing the kind of a, what we say, scatter plot. And with this scatter plot, I got to understand like petal length and sepal length is positively correlated. Are you getting my point? Hello?
Yeah.
Similarly, petal width and petal length is also very positive correlated. Whereas petal length and sepal width is uncorrelated. Yeah. So this kind of understanding we can get using this pair plot. And apart from that, as I mentioned, what uh, We have multiple other plots also. Like if I tell you, we have more data set available inside that, like uh, what we say, uh, a Titanic one. So we can also do multiple plots like SNS dot load. Okay, so if I show you the Titanic dot head, and this is the data survived passenger class X, age, siblings, fall. These are the data we have. Now let's say I would like to do a kind of bar chart with some kind of certain variation. So let's say I wanted to plot a bar chart based on the type of gender we have. We want to check a person either survived or not survived. Zero means survived, one means not survived, kind of thing. Maybe it could be vice versa. And I wanted to check based on the classes. Okay, third, first, which class the person is sitting. So for this, how we make a bar chart with this kind of a estimate and confidence interval. Let's have a look. So here, let's say this is the data, and you have the bar chart in which you wanted to do based on the gender X mentioned here, and we wanted to check based on person who is survived or not survived. Mm, y equal to survived or not survived. And we wanted to divide this based on this, which like the person, male or female, survived uh, based on the different classes the person was staying in that Titanic. So we can define like this. Yeah. And the data we are using. This one is, I'm sorry. Can you see that? So based on first, second class, it has been categorized using color. Okay. And male and female as mentioned. So in male, in first class has been survived maximum, in second class next, and then third. Similarly, female has survived a lot. Okay. And you can see that female maximum again with the class. So according to data, we can understand like money can buy happiness. Got it? And similarly, there are so many plots, right? So you can do multiple other plots too. Okay, so I quickly want you to give whatever we have done today. Okay, this one. And I wanted to go through this and ask me questions related to this. And then we'll do a small case study on the top of it.
Dipesh, I have one just question in that pie chart, right, where we are looking for the teams and the number of wins, right? So there we see that the numbers are getting overlapped and it is not,
Correct.
and even the labels are getting overlapped. Is there
Correct.
any way to, make it sophisticated and avoid that overlapping in
Correct.
this?
We can do that. So basically, there are two ways. You can check on Matplotlib website. By
Hmm.
codes you will get. There are two way. One, you write the text into 90-degree. Okay.
Okay.
Okay. So like it's written like this way. So it is getting one by one. And another way is, like you can increase or decrease the like the text as well as you can scale the text as well as. So there are two options by which you can, like do the same thing in a like the text should not overlap in that case. So like where it is. Where's my
Okay, let me try something online.
this is you're talking, right?
Yes, this one. I think I got something. There is something called axis
Correct. So here
option.
if you just going to take X just
Okay.
here like in I have defined the figure. Yeah. So like I have labels I can define this way. First of all,
There are two things I think I found online which we can use. I've pasted here.
just let me check.
I'll try in mine also.
Equal. You can do equal and tight layout. Yeah, that two way you can do that.
Okay, got it. Thank you.
Yeah. Okay. So good enough. Now, anything else, guys? Anybody came to Seaborn near to that? Okay, let's take you 5 more minutes, 5 to 10 minutes, 5 minutes. Let's go through them, then you can ask me a question. Yeah, so we are done discussing this. Now, if you have any questions. Hello.
Uh, not from me, Dipesh.
Okay, so I'm showing you or telling you one small case study related to, just a second. Mm, Yeah. So here you can see that there is a complete analysis of data is there, how it has been done. So we have one data that's called wine.csv, wine data. So is my screen visible? All of you can see my screen?
Yes. Yeah.
Yes.
Yeah. So that data does have 11 different columns describing the chemical properties and column for quality rating. Now, data sets has following attributes like fixed acidity, volatile acidity, citric acid, residual sugar, chloride level, these are the things, and free sulfur dioxide level, total sulfur dioxide level, density, and then pH value, sulfate value, and alcohol. And then the 12th is quality. Quality is between 0 to 10. Our goal is to discover which chemical properties influence the quality of red wines and to understand how these characteristics influence the quality. These are the major problems that we wanted to identify. First, the goal is to which chemical properties influence the quality of red wine and to understand how these characteristics influence the quality. Right? This is one thing. So for that, we imported packages like Pandas, NumPy, Matplotlib, Seaborn. We read the data. Once we read the data, then we have, kind of we got the types of data, red wine, white wine inside the data. Like we got fixed acidity, everything we got. In which, as we mentioned, we have to filter the red wine data. Yeah. So we were filtering str.contains red, wine red. So once we filter that data, and then we print the quality of wine. So in which the quality 5 is 681, 6 is 638, like that. Now we will do some R exploration of data. So for further exploration of data, I find out the correlation between all the data. Yeah, correlation between all the data. But it is very difficult to look into the numbers and to understand which property is high correlation and low correlation, 12 quality and other stuff. So for that, we have a heat map. So I'll show you a heat map. Mm. Okay, anyways, let me show you here and then I'll explain you later on. So here you can see that talking here. So here it is a heat map. So heat map is what? When I did heat map, sns.heat map, I'm taking the top 12 and largest quality based on quality. The top 12 values I have taken. You can see that. So it is nothing but it's a correlation value. The correlation value that is 0 to minus 1 to plus 1. So based on quality is here in this. Okay. Now, based on quality, we are finding. So based on quality, when we are finding, okay, here you can see that what I have done. First, I have taken K12 columns wine red dot correlation, and based on correlation, I'm finding the top 12 by quality index. And then this is what my data. Now this is my new, data. That's the column that we created. Based on that, we have find out the correlation. And this is my heat map. So when I heat map sns.heatmap, annote means the value will be annotated on that. And this is a type of graph. So we have multiple types of heat map. So it is become easy to understand. How it become easy? One means the highest correlation is yellow and the lowest correlation is blue. This blue, this blue. More it is near to yellow based on the gradient of color, we can easily recognize which having a good correlation with what. So let's say if it is 0.48, 0.48 is the high good correlation. That is, alcohol has a correlation with quality, means there higher alcohol level inside that, the better the quality of wine. Or citric acid. Citric acid are good correlation with fixed acidity. Okay, and sulfate and citric acid both have a good stuff that we can look into that. So that way you understood this, like that's how you understood this quality of wine. And the negative correlation is fixed acidity and pH value like that. So and volatile acidity have a very less correlation between the data. So that is how you understood about the quality and the type of relationship between the data. Did you understood this heat map, all of you guys?
There is one question. So
Mhm.
when you say correlation and you're getting these values, you
Mhm.
said there is a formula for correlation, and the function automatically applies that formula and gives you these values.
Correct. When you do df dot correlation on all the data, the values, the formula will applied, and then it will find the values for that. And the
Okay.
formula correlation formula, as I told you, is nothing but it's a correlation of x and y is nothing but covariance of x and y upon the standard deviation of x and standard deviation of y.
Okay.
And covariance is something, again, if you can recall, we have done covariance in metrics, like so covariance we find out. So correlation, like for that you need
Between
to do,
-101.
yeah, and then xy minus like that. So similarly you need to do that.
Okay.
So yeah, this is the idea behind the correlation formula. So it will automatically find this. This will automatically find, and it's the same kind of, in PySpark also. PySpark also have all these functions available. What we are doing with Pandas. That's why I was telling you Pandas, because when we do PySpark, PySpark have almost all the same features, but different way. The techniques and the everything is different. Okay, but it's walking into the gateway where we can interact with data into very big amount of this, where parallel processing happening. But again, same thing we'll be doing over there as well. As you can even use PySpark Pandas accordingly, like that. So on high amount of data you can use, and on Databricks you can use Pandas. So that's how it will help you a lot.
Dipesh Vasu here.
Mhm.
When this question came up, right, like how to analyze the quality based on different chemicals, you just showed us how the correlation part, to approach the problem with the correlation statistical method, right? But just out of curiosity, I'm asking, like, if there a question changes to something else, or if there is another data from another source to be asked to analyze, is there any basic methodology or steps that we have to follow as approaching the problem? Like, first you try this step, if doesn't give, then go to this step and then try it out, rather than shooting at one and seeing which works. Like, correlation is one of the statistical method that you use to analyze the data, right?
Yeah.
So how would we know as a beginners approaching a problem such as this to use which relation or which statistical method, or start the data? I mean, analyzing the data.
You can do one thing. I have a complete playlist of mine on statistics. Okay, I will share with you, in which I have discussed, if you have a sample data, what should be your approach on that data. So first we go to the advanced statistics, in which we talk about everything about data, how we look into the data, how the data are distributed. So the complete data distribution technique, like binomial distribution, we have chi-square distribution, we have, we talk about the probability distribution of data, so Bernoulli distribution. So and what scenario we use, what kind of distribution of data. So that understanding you should have first of all. After then the hypothesis testing, those kind of things. And these are the basics. So basically statistics divided into two parts. One is the descriptive statistics, and one is inferential statistics. Okay, descriptive statistics divided in two parts, based on based on level of distribution and based on level of central tendency. Okay, so these understanding when you will have, the approach on the data, how your data can give you the best information at what condition, then you will process it. So generally when we teach the data science course and all, so the process that we do is first the advanced statistics part has to be aware, and that's how you dig into this part. Okay, that's how you will got an idea. Like, yeah, I mean, if our data is there, these are the different techniques I need to make it involved with that, and that's how you will able to evaluate.
Gotcha. Thank you.
Okay. That is one way, yeah. And then another way is the like I told you, like in the the descriptive statistic method, in which you got to know about the quartiles of data. So how the data are distributed are going to be you're gonna get by, like, I based on that understanding I have understood these things, like as it can seen from the graph. It is not a very effective correlation between any one of the attributes, but the following dimensions are relatively highly correlated. Means total sulfur dioxide with free sulfur dioxide and something like this. So alcohol with quality, this might be a candidate for drop, because alcohol with quality, something having some kind of a, we say, some outliers are there. So we got some understanding out of this, and then we will visualize multiple things. So this is what I have visualized. This way you can also understand. Then I have done a lot of box plot. So box plot is giving me an idea, like based on the different quality of wines, how the outliers are there. Can you see that? So quality 5 have a very huge outlier based on quality, fixed acidity. I have find out with everything. Can you see that? Yeah. So I have find out with almost all the stuff, right? And then I describe the data. I describe the data. This descriptive statistics also giving me a lot of understanding. How? Means fixed acidity at 25 percentile is 7.1 and 50 percentile is 7.9. Means there is not so much variance in the data. So we could explain the huge number of outliers to the volatile acidity. Correct? This is what we got to understood. Similar reasoning, citric acid seems to be somewhat uniformly distributed, and residual sugar minimum 0.9 and maximum 15. Too much difference, right? So this could explain the outlier. Similarly, a residual sugar minimum is this much and maximum is this much. Free sulfur dioxide, total sulfur dioxide have same explanation as above. Correct? Then this is point plot where how the data are distributed based on the quality. This is the observation we got. Means great wines are in balance with their 4 fundamental traits: acidity, tannin, alcohol, and sweetness. As the wine ages, the acidity acts as a buffer to preserve the wine longer. Are you getting my point? Like with the data, we do understand these kind of activity by looking into some kind of insights. Yeah. And we can infer from the graph that the higher quality wines have a comparatively low pH and high acidity.
We can call it as a negative correlation.
Yeah. Means those who have a higher quality of wine have a lesser pH value that we have observed from the data. Yeah. So when there is a negative correlation, it's a good, the quality of wine are better. And multiple other charts I have find out, and I did made a complete kind of a case study out of this. So this is one of the case study, just a quick understanding of this problem statement. Why I have told you this, so that you understood, like, let me just share this with you so you can iterate this later on. And I am going to give you one problem statement that you need to solve for tomorrow. Okay. First, let me share this file.
Ritesh, so all these is part of EDA of machine learning, right?
EDA explore. See, what is ETL? How do you define ETL? You wanted to do transformation, right?
No, I mean to say EDA, not ETL.
EDA. Yeah. No, I'm saying even if either you're doing EDA or either you are doing ETL, somehow before you do transformation, you need to understand your data. You need to understand some business reasoning behind that. While even if you are storing into the data warehouse. So there is a concept of ELT. Okay. So what we are doing is a kind of ELT. We are loading and then transformation. Transformation we are doing. Yeah. Do you know the difference between ETL and ELT?
Yeah.
Yeah.
So
So
somehow,
we,
yeah, this what we have done. Somehow it is kind of a ELT. Where first we are getting the data, understanding the data, and then later on we are supposed to gonna do the complete transformation on the top of it. So let me share this with you.
are you saying that we will be more of doing ELT process rather than ETL when it comes to building these data pipelines in Spark and Databricks?
I'm not saying like that. It is totally depend on your objective. It's totally depend on your objective. But when you have tools like Spark and all, okay, which have a capability to analyze the data, okay. So in that case, this giving you a complete accessibility to look into the data, doing ETL, ELT, data warehouse, everything that is allowing you to do Databricks and all. So what are the opportunity? See, the idea is that with the data, what is your objective is to do business decision, and business decision will be happen on huge amount of data. So when you have a huge amount of data, how you going to deal? You will of course going to do capture rate. You have a lot of other issues with that. You are supposed to going to transform on a very higher scale. But before you are making any changes, you should have understanding about your data. All right, right? So these kind of scenarios, conditions, you will able to do that. Either even after doing your ETL job, if you're just doing the data analysis on the top of it, you can do that.
Yeah, so you mean to say EDA may not be specific to machine learning, it can also be for the ETL or ELT?
What?
No, EDA may not be specific to the machine learning or data
Yeah,
science as such. It
EDA is
can
not
still be
specific for
used
the machine
to
learning.
analyze the data.
Correct.
Okay.
EDA never be only specific to machine learning. Machine learning is specific is again, see, machine learning is a different concept, right? EDA is just to understand data, understand the opportunities related to business, right? Machine learning is just getting those insights and mining the data later on the top of EDA's result in such a way so that they can prepare a model, a kind of a model that able to do kind of multiple machine learning activities like recommendation system or multiple other objectives that we wanted to achieve out of it. So EDA is allowing you to do a better ETL, or EDA is allowing you to prepare your data in a more better way, in a precise way, or to even after the data warehouse, the data has been concept to analyze the data in a better way.